Hello all, welcome to the show. I'm Gus Gagliardi and this is Fire Code Tech. On Fire Code Tech, we interview fire protection professionals from all different careers and backgrounds in order to provide insight and a resource for those in the field. My goal is to help you become a more informed fire protection professional. Fire Code Tech has interviews with engineers and researchers, fire marshals, and insurance professionals, and highlights topics like codes and standards, engineering systems, professional development, and trending topics in the industry. So if you're someone who wants to know more about fire protection or the fascinating stories of those who are in the field, you're in the right place. Construction industry. In this episode, we're talking again about automation. This episode specifically talks about automation that can benefit engineers, contractors, but the topic of automation and how machine learning, AI, and other big technology concepts can apply to professional life in general is really ubiquitous in the discussion of how to become more efficient as a professional. Sean is a trained mechanical engineer and he gives great tips for people who are interested in the cutting edge of technology, and if you have a proclivity for coding, automation, BIM, Revit, or any of the above, you're going to really enjoy this episode. Don't forget to subscribe and follow us on social media. Also, if you could do us a huge favor, give us a 5-star review on Apple Podcasts. Let's get into the show. Really enjoy this episode. Don't forget to subscribe and follow us on social media. Also, if you could do us a huge favor, give us a 5-star review on Apple Podcasts. Let's get into the show. Well, Sean, welcome to Fire Code Tech. Thanks for speaking with me.
Hey, thanks for having me. Always good to talk about automation.
Yeah, automation. I'm down to talk about automation.
Who's not talking about automation?
I don't know. It seems like AI, and I keep thinking about AI and machine learning and automation and how that's going to apply to our industry. But yeah, I don't know. We could just get right into it if you have thoughts on that. Have been trying to pick up a little bit of Python in my spare time and thinking about machine learning, and it's not so clear to me. Automation part's clear to me how that would apply to our industry. But do you have any thoughts on AI and machine learning and what we'll see in the future for those kind of buzzwords for what you and I do on a daily basis?
Yeah, I don't know. I haven't jumped on the machine learning bandwagon. I think it's more of a buzzword. No one really understands the amount of data that you need to make it work. So we have to get a lot better at other things before we can start machine learning our way to success. We have to, right?
Yeah, I was thinking if you had thousands of projects and thousands of device layouts, really you need 10,000 plus would even, I bet, would be a small data set for some of these machine learning projects.
Right.
So you would need so many projects in order for it to be meaningful. So yeah, it seems like just the baseline automation stuff makes a lot more sense.
I got in a debate with a friend of mine who's working at a firm that's really progressive, and they are working on starting to implement some machine learning stuff. And they're just trying to identify plumbing fixtures. So we had a fun conversation about that, but I'm like, right, it's only getting you this 5% more. And so all this work has to go in just to get that extra 5% success. But it's wouldn't it just be easier if the architect called a sink in a standardized way? I think that's the approach that we should take. But obviously that's had struggles too. So to my point, I don't think we can get to machine learning if we can't even call a sink in a consistent manner.
That's true. Yeah, I think that as with most things in automation, the true value of it is to be found in the repetitive tasks that you do every day, and then eventually you can get to these kind of high-minded ideas about really complicated stuff.
Yeah. But I will say, I think there is a lot of potential there. especially for maybe like
Yeah.
auto routing and stuff like that, right? You can almost turn that into a simpler like 2D problem. So
Yeah.
there's so many algorithms out there. Like maybe that I just heard something about like they're trying to map the what is it called, the galaxy like web, and they're using some type of algorithm that's based off of some type of mold, I think.
Huh.
And so I saw that like YouTube video on that, and I was like, oh, maybe that could work for like auto routing, you know?
Huh. Yeah, that makes sense. I mean,
So
yeah, that auto routing is a really interesting topic.
yeah, it's a really hard
And,
one, especially fire protection, right?
oh yeah, fire protection and fire
You
sprinkler
guys
and
usually like the
fire
last ones to
alarm.
go.
Yeah, it's a dynamic we talk about a lot inside the firm that I work for. Is like fire protection is such an odd bird in the sense that there's so much delegated design that's baseline in our industry. So the engineers by and large will just like shove off the task of actually routing to the contractor so frequently. So it just causes more consternation in the field and between disciplines, and HVAC guys mad because the sprinkler guy got in first and routed wherever he wanted it to, and then just said tough. Even though we do our best to try to make sure that people coordinate, contractors coordinate, and we require coordination drawings and our specs, but it's always a pain.
Yeah. I personally think we kind of designed buildings completely wrong. Right, like we try to lay out the architecture first, which of course there needs to be like a form, but as a mechanical engineer, I'm used to getting a detailed architecture model before I even start running ductwork with ceiling heights already in the model. And then, right, it's always the battle of I need more room for my ceiling, and then not wanting to do it. Where, right, if you kind of have the form of the building, obviously, kind of generically what spaces are, but then you could start to route maybe like the mains at least using algorithm and even doing plumbing, fire protection, all that together, and then build. The architecture's job should be around building around the infrastructure, right?
Yeah.
And making it look good, have them creatively, how do we hide this infrastructure? You know what I'm saying?
Yeah, it seems like a chicken or the egg problem. Like
Right, exactly.
What needs to come first?
And speaking with the biology, metaphor, I mean, again, I don't think if you watch a baby grow, right, it starts with like the spinal cord, like the brain, the spinal cord, and like the limbs and everything grow out from there. So you almost have to like think of the building as having like the spinal cord for the infrastructure and then build around that.
That's an interesting thought. That makes sense from that. I would think that an engineer would think that, though.
Yeah,
Isn't it always the quintessential battle between the architects and the engineers over,
I worked at a startup called iBuilt, and it was kind of a disaster, and this was one of the reasons why. And so I came in late in the game, but also I was in charge of like all the mechanical stuff. And they're having me design the mechanical stuff around their structural stuff and around it was a modular. So just around all these constraints, I was assigned to figure out the mechanical. And I kept on saying, right, like, no, the mechanical is, you should be designing structural architecture around the mechanical, not the opposite way around. And the owner of the company never really got
that. I could see that. I've never been able to. At least you could have that conversation. I feel like fire protection, unless it's just like some really specific instance, like with storage sprinklers, sometimes we get into situations where we're pushing around the structural engineers, columns and joist layout, because if you can't fit these storage sprinklers into this space, you can't build the space. Like you
Right.
can't sprinkler it, you can't get a code compliant building layout. But
Yeah.
barring that,
One of the things in modular was like, all right, how are we going to bring fresh air in? Like that was the number one question, at least in my mind, was like, how are we going to bring fresh air into the space? And so my idea was to go to the outside wall, and now we're trying to do modular and keep it all tight. So then it was like, okay, we're trying to design these things as modules, right? So like, how can we have repeatable pieces that come together, right? So like a kitchen module might have a closet in it, and my idea was to try to get really small HVAC equipment, but to maybe go in that closet that would act as like also act as the washer and dryer closet. And then we'd have to go out in the wall. Well, my idea was like first put ideally where the HVAC equipment should be, and then build all the structure around it. They were doing the opposite, where here's the structure, tell me where I need to put the HVAC. So
yeah, those working with those seems like there's always constraints, but the more heavy the building and or site constraints, just the more difficult the entire process is. So I think modular is like the extreme of that constraint. I mean, you're like the whole idea is to get it as confined as possible, or just kind of these succinct little pieces. So
right.
that's interesting.
It's almost like putting, right, if you always have the analogy of like if you're trying to like put a bunch of Legos back in a box, and what is it? If you put all the small Legos first, then the big Legos aren't going to fit.
Yeah.
Okay? So it's almost like that with the structural or the architecture first before the HVAC.
Yeah. I think that's a interesting way to think about it. I guess we'll just have to get faster in the automation and the prototyping to where that is like we can have a conceptually generated layout that's quick so that we can raise that red flag fast. But there's so many options for mechanical engineers. I mean, like fire protection sprinklers are straightforward. Like you got like what maybe two most common system types. Wet or dry sprinkler systems. There's no like manufacturers really that are driving these big configuration changes, but
How much
mechanical is like,
variation do you guys get with building code?
I mean, a lot
Yeah,
of
that's
variation with
another
building code.
huge thing to tackle.
Yeah, for sure. The jurisdictional stuff is the biggest variability, just as far as like military versus commercial versus you could work for Department of Defense or VA or what all these different government
High
entities
rise, low
have high
rise,
rise,
multi-family,
so all that like has
schools.
a big impact. Yeah,
Yeah.
and auditoriums and stuff, but yeah, so I know that we've had, for the listeners just tuning in, we had some technical difficulties on the first go around. My recording program just was giving us fits, but I wanted
Technology
to,
for you.
yeah, that's classic problem for technology.
I
But
can't open up Cloud
one,
Files today with Revit, so
oh yeah, cloud. Wait, what is it? What kind of walls with Revit?
I'm having trouble opening up Autodesk Docs models right now.
Oh man, yeah, it's like that one day when everything Autodesk's cloud client went down. It's like I was like, well, Autodesk never goes down. Surely it's not that. And then you get the email and it's like their whole cloud server's down for a day or whatever. I forget when that was, but
And
it seems like
technology
there's
feels
always
like
something.
it's harder. It makes things harder.
Yeah, but I wanted to let people know a little bit about your background, and you could keep it abridged, but
Yeah.
tell the listeners about kind of your working history and kind of how you found your role now.
Yeah. So I am a mechanical engineer, degreed, got my EIT. Still want to get my PE. So work on that. Just one more test to take. Um, yeah, so going through school, I had my first internship at a HVAC firm in St. Louis, and I hated it. They were just starting to play around with Revit. I actually remember I somehow I got access to Revit, and to get the internship, I like pretty much printed out a model of somebody else's work and threw some ducks in there and was like, "Look, I know Revit, guys." Um, but yeah, I was left doing a whole bunch of CAD stuff there, and like, dude, they had me like photocopy stuff. So I saw a lot of manual. I was the lowest man on the totem pole, so just a lot of manual, tedious stuff, and I hated it. Then I got like a year and a half long co-op at a place called Tech Manufacturing, which they like are a CNC shop for aerospace parts, and so that was really really cool. So at Tech Manufacturing, I guess I should back up. In college, I started learning Excel. That's I think where the story should begin. So in college, I started learning Excel, and we got really good at it. Me and my buddies that we had to do labs with. So we had labs. You have to make these Excel spreadsheets, and before even the lab, we were doing it. And so I was starting to get good at Excel. The firm that I had my internship was using a lot of Excel, and there's this old timer, awesome dude, taught me even more. He was always showing me little tricks in Excel, so I was getting really good, which led me to, I think, in the co-op job, because they had an Excel spreadsheet that was just the most insane thing I've ever seen. So they would bring in, so like Boeing or Lockheed would like give these packets of all these parts. And my job was to like find the bounding box of the part, right, for the raw things. Get out what material it is. So it might be aluminum, might be titanium, the grain, which way the grain runs. So you just had to like pull all this information out and then put it into this Excel document. And then at that point, it would just kind of do its thing. And you did some other stuff to try to get an estimate on the CNC time. But like, dude, this thing had so many formulas and so many sheets. At the end of it, it even calculated like shipping cost and all this stuff. And it made what was called like the red sheet, I think is what they called it. And it would be like this big review of all the parts, and they'd say yay or nay. So all the higher ups would come in and we'd review all the parts after all this information is populated in Excel. Like I said, it's giving you cost. It's gave you everything you need to know to say if the part is, if they're going to bid on the part, what they're going to bid, and if they'll move forward or not. So I was just like, this is really cool. So I learned even more Excel there. That internship or co-op was up, and I needed a job. And guess where I landed? HVAC designer, the thing that I thought I would hate. So, yeah, luckily at the time, Dynamo was starting to become a thing. And again, my Excel, I was like, oh, Dynamo can get stuff from Excel into Revit. So that started. And then I realized you could do stuff with geometry, and then snowballed from there. Now I've been consulting for 4 years, building custom workflows for clients.
That's very cool. That's neat that you had that saw the power of this kind of automatic calculation and kind of streamlining of a very difficult and unique process. And so you kind of had that seed planted early in your career for the possibilities.
Yeah, for sure. Before all that, by the way, I worked at restaurants for like my early 20s. And I worked under this guy, Vito Racanelli, who's now the executive chef for Anheuser-Busch. But he's like a Gordon Ramsay type. And he was all about, I started with him when I was 16. And so he is all about efficiency. So I think that's maybe when it was really embedded in my mind. But then it just got reinforced in all these, other little adventures I had.
Interesting. When you're talking about, you make custom kind of like Dynamo and Python like solutions, is there anything like, you don't have to get specific on specific projects or tools, but like, can you give examples or maybe talk a little bit about your project work and give the people listening some ideas of these applications?
Yeah, I mean, I guess there's anytime the first big success I had with Dynamo, I think, was setting up projects. So I missed a softball game one night, and I was really disappointed. But the night it was literally spent, we're behind. It was a huge hospital. I forgot the sheet count, but I had to work overtime, literally dragging sheets and legends on, or dragging views in legends onto sheets. Like, it was so silly. So yeah, Dynamo again was starting to mature, and yeah, just automating that whole process down to a couple clicks was like, whoa, this is crazy. So that's first. So any like little things like that, especially in things that have like a very defined recipe, is good for that. So now I've done that with like setting up electrical panel schedules, sheets, and doing a whole bunch of stuff like the annotations. Like there's like this annotation keys. I guess another advanced thing that I did that was really cool was working for an electrical contractor. So we made a thing called room in a tote. So it would go into the Revit model, and you pretty much section the building off by essentially rooms. And the whole idea was we'd get those elements, we'd make cut sheets for all those elements, bill of materials for all those elements. And then in the warehouse, all the elements, the instructions, and the tools, like all the materials, I should say, not elements. So actually the materials, the instructions, how to install the materials, the tools needed to install those materials would all go in a tote and be shipped to the construction site. And that tote would make its way into the room. And then the tote would open up, and the electrical guys would do their installations.
Wow. So you're doing like material stock listing basically from Revit model?
Right. So directly from the Revit model. And these guys, the company hired a lot of people from the field to do the detailing work inside Revit. So like they were doing detail work down to like the bolt.
Wow.
Which we were pushing our computers so hard to do this. Yeah, it's really cool.
That's very advanced.
Yeah. So we'd go through and like make cut sheets essentially, like get the front view, the side view, the 3D view, the back view, of every electrical panel. And then boom, bill of materials. And then, there's multiple layers of it. So stuff would build up from like, bolt level to component level. And I forgot the little details of how we did it. But, in other words, you went from Revit model to all the parts that you needed in a tote that got shipped to the construction site.
That's really cool. That's for people who maybe aren't as aware of like Revit and the common detail level. I mean, like that's like detail level 500 there's kind of like different gradients of how much detail is. You can go from like 2D annotation with no information tied to it all the way down to where Sean is saying where the bolts and the rivets on a piece of equipment are detailed. And so there's kind of a sliding spectrum, and that is on the extreme end of like, I'd say most commonly in the architecture, engineering, and construction industry, you're at like the middle of that spectrum, probably like 200 or 300 level of design. You have either 3D models with a limited amount of information or 2D models, or at least that's in my experience what I've seen in the industry.
Well, I even like the idea of analytical models, right? So we're seeing more of that happening where you're not even physically modeling stuff, but you're starting to use Revit more as a design tool rather than a documentation tool.
Interesting. Yeah.
That's, I guess, if I add on to another thing that I've done. So my favorite script I've ever written for mechanical engineering is like zoning a building. And it's just, speaking of machine learning, so that like uses some clustering algorithms, like k-means clustering. And it was a silly problem to solve of just how do you like group these things. And that was the solution, was clustering.
Interesting.
And I think that can snowball into a whole bunch of other stuff, but also just allows you to start doing, using Revit as a design tool.
Huh. That's really interesting. So you would establish HVAC zones based on your automation?
Yeah, so it's all about data, right? So you have a whole bunch of spaces in a building. To zone a building, like common spaces usually get grouped together. So spaces like the same thermostat set points, right, could be grouped together. Exhaust might be grouped together. On exhaust fan. Exterior spaces, right? So north exteriors would be grouped together. South exteriors could be grouped together. Different window sizes, right? If you have two rooms next to each other, one has a lot more windows, then they wouldn't be grouped together. But right, so you can use all this data to kind of start grouping these things together, and then you're left with like these clusters of spaces that now you have to divide evenly. And so you can't just like draw a line in the middle. You have to like try to find the right clusters of spaces. So that's where the clustering comes in. And then so then you can actually do like a decent zoning. And it got to the point where we took this to production and we actually put like sliders on stuff. So you could limit how much area is on one zone. Set a max or min to that. You could set a max and min to like, the load difference into the spaces you're comparing. There's a whole bunch of sliders on it. So you can start to generate different zone layouts with the same script. Yeah. What I'm trying to get to, what I think is really cool and kind of my North Star right now, is then taking those zones and going to energy modeling. So now you could run, in theory, right, a whole bunch of run energy models on a whole bunch of different systems and, even get, upfront cost and life cycle cost and all that. Sounds really familiar to what I was doing at the manufacturing plant. So,
Man, that's awesome. That's such a time-consuming process, I'm sure,
it's crazy.
establishing all those
When I was a
zones.
designer, again, when I was low man on the totem pole, just watching all this stuff, I'm like, this, because they're doing all the calculations to like, decide which system to pick. And then you have to like write, we went through system A, B, and C, and we're picking system A because of X, Y, Z. And it was really time consuming. Yeah. So Revit has access now to Energy Plus, which is what I've been working a lot on.
That's awesome. Yeah, and I can see, application to this for really so many engineering systems. Like, I mean, easily for electrical, definitely for fire protection, and, other disciplines where, equipment zoning based on whatever parameters you want to build in, whether it's voltage drop or, friction loss. All that. I could see just so much potential for that.
Right. What's kind of cool is too, I've thought about it with electrical a lot and I haven't done it yet, but like, taking receptacles and grouping those for panels, right? So that's what I've seen. So with doing the stuff that I was doing with the electrical contractor, like when I was doing that, I was really interested in like automating the process before the processes that we were automating there, because we were just automating the documentation. And already I was looking at like, how do you guys know what? Like, because they're having to put in a lot of information, right, to make room in a tote work. So it's like you just keep on knocking chunks out of the thing. And that's why the zoning algorithm was so exciting to me, because it was a huge whole bunch of people told me it couldn't be done. And it's like, and I didn't believe that. So, it was just like, it was this huge gap in the workflow. And to solve that gap was just really cool.
Isn't that the start of any good story? That they told you that it couldn't be done? I
don't know if I'm there yet. I haven't won the automation princess yet, but.
Oh, do they have awards? Is that a thing?
I'm just saying, hero always
has
a struggle.
The virtual automation princess. You haven't gathered her out of the castle?
Yeah. Hopefully it'll happen in my career, right?
I mean, you're off to a good start. That's fun. I like thinking about these big ideas and yeah, holistically looking at how can you take the whole process and kind of make it into discrete chunks for everything to run smoothly is a really fun idea.
Yeah, I think that's what I'm really good at. I'm a dyslexic, and so if you read stuff about like dyslexics and what they're good at, like exactly what you just said is exactly what like typically dyslexics are good at. And so yeah, that's kind of like my superpower now is being able to zoom in and out of like these big problems and just make the connections. Um, yeah, it's fun. I love it. It's solving puzzles and problems all the time.
Yeah. So I'd like hearing your big thoughts on like the future and what you'd like to do with your consultancy. But yeah, like what else is getting you excited and do you want to do with automation or like what kind of gets you charged up on a like a project level or just like an automation conceptually? I'd like to keep chasing that thread.
Yeah, I mean the whole reason I started the consultancy was not to get rich or anything. The whole reason was I wanted to do what I wanted to do and work on the stuff that I wanted to work on, and I couldn't find that avenue. Um, so yeah, I guess I didn't mention this earlier, but yeah, I quit my job as a mechanical designer because I knew I wanted to like pursue automation, and I tried to find a job around Dallas to do that, and I couldn't find one. So that's when I started the consultancy. As far as motivation, I think my Northern Light has always been this vision that I've kind of already described of getting an architect model and then being able to quickly generate a whole bunch of different options for the HVAC system. And I guess branching that off into plumbing and electrical would be awesome. And then I guess the like end game would be if you could do that and start to optimize with all the systems and architecture and structure all in one algorithm. Which,
Man, there's a
right, I
billion
don't know
dollar
if we
idea.
can get there. I think in theory, but of course it's just like right, computational time is a struggle. Maybe with quantum computing, right? Throw another buzzword
Those
in.
computers are getting bigger and bigger and faster, so you
Right. So
never know.
maybe that is how we're doing buildings with supercomputers and just algorithms. Yeah, I guess it gets into like kind of your thing of like where the industry's going, and I don't know. That's where I'm. That's where I see it going. That's my Northern Light. It's also kind of scary, right? Once if someone beats me to writing that algorithm, am I out of a job? But so far, it's been kind of proven not to be the case, right? So automation's going to take our job. South Park reference there, right? But it hasn't, and we are still talking about. We started off talking about the struggles of data and data entry, and so there's like these two forces. There's these entrepreneurial spirits that are pushing really hard for automation. But then there's just like this force holding it back due to like, I almost want to say like people problem with just understanding, right? Just understanding, how databases work, understanding computer science. Building code, I think, is holding us back, right? I think we need to digitize building code if we're ever going to write an algorithm like that. Because, right, if you, like we were talking earlier, if you change one thing, that changes the other.
Yeah, that's an interesting thought. And something that I've thought about a decent amount because, like if you take a look at this company, Upcodes, who is
Yep,
a
definitely seen them.
somebody. Yeah, so they want to like make the kind of take a tech angle on the building code, and there's been a lot of litigation over that.
Yeah, I was
But
about to say that was huge. The fact that they won that was huge.
yeah, definitely. So, and I was watching that closely because that kind of if you don't have free license to work with that data set, then like, what are you going to do? How can you innovate on top of that? It's like,
Even
um,
upcodes, though, isn't really there to what we need. Like, I played around with upcodes a lot, and it's great.
yeah,
I know they're trying to do some compliancy checks, automated compliancy checks, but my the something else I've been thinking a lot about, and I went to Built recently, and I was asking everybody. Um, it's hard to even formulate the question, but like you start having all these databases connecting, and we all know the pictures that you see, but it's like, how do these things really connect? And then it's like, how do you take that stuff to scale? And so the example is, let's say I have an algorithm that is diffusers are to. I'm going to make it real simple. This is not how it's written, but like diffusers are placed 10 feet apart, right? That's the algorithm. Supply diffusers placed 10 feet apart. Code A, right? So then you're reading, you go, now you're doing a project somewhere else. And this one says a supply diffuser will be placed in the center of the room, and the exhaust diffuser will be placed by the door, right? Human language. How can you build a system at scale where you can just keep on adding those rules in? Right? So next, you know what I'm saying?
yeah,
Next rule
yeah,
is code or whatever, for whatever reason. Rule number 3 is slot diffuser goes on window. You know what I mean?
yeah. The flow
Um,
control for such a big process is
right.
really
It just
difficult.
snowballs on you so quick. And I bring up diffusers because I was thinking a lot about this with just diffusers recently. And yeah, so I've been thinking a
Yeah,
lot. So yeah, bringing back to Bill, I asked a whole bunch of people this question of like, how can we start to do this stuff at scale and like make a system that you can just add more layers on top of really simple, right? The only person to give me an answer or a path to even start to go down was Ian from Hypar, who's actually the creator of Dynamo. I forgot his last name. Sorry, Ian. Yeah, and so they're working on this thing called Hypar, which is really cool. But they essentially build things that are functions, and the functions wrapped inside the functions is kind of like that design logic. Is the elements that use that design logic that get placed, and so then their kind of workflows to layer function on top of function, which again is kind of getting back to the idea of like function A will make floors, function B will divide the floors into offices and corridors and whatever, right? Function maybe Q would be right now put in diffusers. Function Z might be right now route ducts.
mm,
Um,
yeah.
so they have a point. And his thing was talking about this. He recommended that I look at I have the book. I forgot what it's called. Expert systems. So I've done a little bit look at expert systems. I think that's kind of a route, and that's a lot older than machine learning, by the way.
Expert Systems. The book
Yeah, so there's a cool
is
book. You want to know the book title?
Principles and Programming.
I mean, it's not even just programming. It's more of like a way to structure data in a way.
Who's the author?
Um, Expert systems, principles in programming. Josh C. Giarratano.
I'll throw a link up in the show notes.
But it's also, and another thing that I've been thinking a lot about is, right, we have a lot, like the turnovers happening in the industry so bad. And like, so a lot of senior engineers that have all this knowledge in their head. And again, that's not just like building code. Like, there's also this database of knowledge. It's just like we have building code that's in written word, right? And that has to be translated into some type of algorithm rules. There's also the knowledge in all of these engineers' heads that has to be translated.
Oh no, sorry, keep interrupting. I was going to say read a terrible. article today they were posting. They said 25% of the professionals in fire and life safety think that their knowledge transfer is being completed from people aging out of the industry. So like, there's just this terrible loss of industry specific knowledge, and like you're saying, this turnover, this exiting of this long standing knowledge base from the industry is a huge problem.
So yeah, I guess back to the question of like, where do we go or what's it going to look like in a few years? I think it's an open-ended question. When I was at Built last time, I actually left pretty pessimistic because I'm fairly new to the industry. I'm like 5-6 years experience now. And right, COVID happened, so we all didn't see each other for a good 2 years. It's a tight-knit community at that conference. And we all come back, and we're all talking about the same problem. About data and standardization, and how do we implement this in our firm. And I'm just sitting there thinking, if I retire and I'm still having these conversations, I'm going to be very disappointed in my life. Like, you know what I mean? And I see other people there that have been there for have way more experience than me. I mean, there has been some success of going from like AutoCAD to Revit, but yeah, I don't know. I hope we're on like the exponential path. Right now, it seems pretty flat, but soon we're going to take off. So I guess that's to wrap up that question. 2 options, right? We either stay linear, pretty much linear, flat as we have been with our efficiency in the AC industry, or all this technology that we've been talking about finally gets us to, go off exponentially.
That's interesting.
And we need the exponential to happen, right? Just with everything going on in the world.
Yeah, I believe that it's going to happen. To me, what makes me excited is just like how I can finally see companies or individuals like you even existing. Like the fact that you and Maj do exist, and you are making good content and automation, and then you have companies that are becoming, huge critical successes like D-Roots and stuff. So, I mean, look back 20 years ago, and we didn't even have companies doing custom software. I mean, right. Like in the AEC industry as a business.
Right. I consider myself so lucky. It's like,
it's incredible.
It's just crazy I came in at the right time for like there to be this opportunity. Yeah.
Yeah, it's awesome. And so that part about it just makes me think that we're just at the launching point of this automation trend, and in the next 20 years.
Testfit? Have you seen Testfit? Mm-hmm. Wow, you need to look at Testfit. They should be on your podcast too, by the way. Shout out to them. But they just got $20 million in funding or something.
Oh, wow.
Yeah, I mean, that's just one example of a lot of startups. You brought up Upcodes, Cove Tools, kind of working on energy model stuff I'm working on, actually. Yeah, another question to ask, will Autodesk always be the top dog in the game?
Man,
Autodesk stopped Testfit from having a booth at this year's Autodesk University.
Oh, wow. That's incredible. I was talking with Majd about who's going to be the Autodesk killer, or if there was going to be one in our lifetime. And he, kept boiling it down to like whoever can really capture the holistic picture of the building and all the engineering disciplines would be the one to rule them all.
Right. I think Hypar, Hypar's another one. I think they have it. What's really cool to me about Testfit, and what I've always seen, is they're pretty much doing like they're doing Testfits. That's the name where it comes from. Uh-huh. So they're like, you give a site, you draw out a polygon, and it just starts like creating multifamilies, and they keep the ratios between like, units and parking stalls and stuff like that. But what I see is this really simple geometry. And back to my original thing about like how routing MEP stuff, how we're doing it wrong with trying to do it when it's really complex. We have a really complex maze. Well, what Testfit's output is just like pretty much like massing. So then I've always wanted to layer MEP on top of that. Because I know what their output's going to be. Like, I know what I'm getting, right?
Yeah.
And it's simple. So those two things right there. With those two things makes energy modeling a lot simpler, makes, like auto routing algorithms a lot simpler. So I see someone like, that's what I see with Testfit is because they started at the very beginning stage, that now they can just keep adding. One of the things as engineer, to build custom software as an engineer is you don't know what you're getting from the architect, right? So that's like the biggest struggle that I see with writing tools for architects, or writing tools for engineers is, right? We don't know what the architect's going to do. And I'm like,
the input is so variable from what the architect can provide.
Right. It's a very frustrating thing. Again, one of those times where I always get told I'm wrong. But I'm always like, or like they don't have control. But I'm like, write it into your BIM execution plan. Hey, architects, we expect this parameter to carry our firewall rating. Is that how you guys do it? If not, okay, let's change it. Or can you please do it that way? Here's why, because I'll save you so much time on the back and forth. You know what I mean? So there's countless examples of that when you go from architect to engineering. That the data drop, the model transfer.
Oh yeah, it can be done just like 100 different, like a 1,000 different ways.
Why use machine learning when you can just write a simple BIM execution plan? Find an architect that understands automation and what's needed, right? So, yeah, I don't know. I guess the business models have to change. And I'm not an expert on the business models, so.
Yeah, but it's fun to think about it. I think that's funny that you're like, let's start with mechanical, because
maybe it's good to be naive and not think about, not understand the business models, because then you can come at it with a clean perspective.
Yeah. Yeah, I mean, I think that's awesome. It makes me really excited to see things like Testfit, and for those who are interested in taking a look, looks like it's mostly kind of residential and building development projects for developers, and kind of this blocking and programming sort of early design phase, like even before schematic design, kind of programmatic design phase. And, anybody who is aware of the money involved in the development for these type of facilities would quickly realize how much market capture and money there is for this type of service. I mean, it's immediately seems like a no-brainer from, whatever, 3 minutes looking at it.
I keep on bringing up Ian. Ian told me one of the first times we first met, when he was starting Hypar, was, and I use it all the time in so many presentations, it's like, why are we starting off projects with a blank screen? Right? And Testfit's a perfect example of what we could be starting projects off with.
What is Hypar? What do you keep saying? I don't know what that is.
Yeah,
That like
look
a company?
Hypar. It's hard to explain what Hypar is. I think they're struggling explaining what it is.
Hypar.
Another person you should have on your podcast.
I would love to.
I'm going to leave it there. I tried to explain it earlier. The business model is kind of, I've always looked at the business model as like, because they're trying to bring like a community kind of like Dynamo sense to it, but it's like, it's weird.
That's interesting. Well, maybe I'll do a solo cast or something about it. But interesting stuff. Well, you got a lot of different perspectives and people so far that I've never even heard of. So I appreciate all that perspective. But so for people who want to get started with Dynamo or for automation, like, where would you suggest that they start, or resources that they should investigate?
I would start with having a problem and trying to solve it in a simple problem, not a hard problem. I say this story real quick, or just thing. I learned through consulting, like when I first decide to work with a client or not, one of the big red flags that I get is when someone's like, I want you to auto route MEP for me. Like, to me, that's a huge red flag, because if that's just that simple of a statement, they have not taken the time to think about the complexity of that problem, the amount of data that's needed to even start thinking about that problem, right? Because where are your sources and where are your targets? Is that data in the model? What do you want to avoid? How is that data in the model? Are we going to do it in 3D, 2D? Why not 3D? Because it's really, you know what I mean? Like, just if you ask for something like that complex, then you don't have a grasp on what it takes to build the tools. And you don't have an understanding of the data or the geometry behind it all. So again, if you're trying to get into automation, start with a task. Don't have it be auto routing. Have it be like getting data from Excel to Revit. That's where I started. Setting up projects, putting legends on sheets, something that's relatively linear, you know? And there's a lot of tools out there. There's VBA in Excel, there's Dynamo, there's Python. Dynamo, if you're working in Revit, is probably your easiest, best shot. Get hooked, and then, just keep on learning until you can never stop learning. So I guess that's what I'd say.
Well, I think that's a beautiful point to end on. Keep learning and never stop learning, because that's something that I'm throttling myself.
That's going to be the guarantee, right? The Northern Star is to automate. Northern Star. I want to have in Star Wars when they have like the Death Star plan. That's what I picture.
It's what you want for your flowchart, for your process and your dependencies.
I want a hologram in the middle of a desk where I can flip some knobs and just the MEP infrastructure, right? Just like you see the generative design stuff, just switches, and you get just like the red sheet at the manufacturing facility that tells you the critical information. And then we all sit around that desk and we debate and we have conversations about, the right choice. And to get there, yes, never stop learning. Because it takes so many hats to pull that off. Probably hats that we haven't thought exist yet.
Yeah, I like that. Well, that's a good note, Sean. Well, where can people find you if they want to reach out to you about custom Revit solutions, or if they want to learn more about your company?
LinkedIn, email, website, YouTube, Twitter. Usually my name, R Sigma AEC Solutions.
Cool. Well, I'll throw some links to your consultancy down in the show notes if people want to come find you. But thank you for coming on the show, Sean.
Thank you. Good conversation.
Thanks for listening, everybody. Be sure to share the episode with a friend if you enjoyed it. Don't forget that fire protection and life safety is serious business. The views and opinions expressed on this podcast are by no means a professional consultation or a codes and standards interpretation. Be sure to contact a licensed professional if you are getting involved with fire protection and or life safety. Thanks again, and we'll see you next time.